Hello students. Today we start our lectures from this problem. The problem is a random sample of 5000 pineapple was taken from a large consignment and 65 were found to be bad, so that the SE of the proportion of bad ones in a sample of this size is 0.015, and deduce that the percentage of bad pineapples in the consignment almost certainly lies between 8.5 and 17.5. Now here's the solution. Here we are given n equals to 500, capital X equals to proportion of bad pineapples in the sample, which is 65. Okay, it's 65. Small p equals to proportion of bad pineapples in the sample, that equals to 65 divided by 500, that equals to 0.13. that implies that q is equal to 1 minus p equals to 0.87. Since p, the proportion of bad pineapples in the consignment, is not known, we may take as in the last example pq cap, its p cap equal to small p equals to 0.13 and q cap equals to small q equals to 0.87. Therefore SE of proportion equals to root over p cap q cap by n equals to root over 0.13 into 0.87 divided by 5000. It's 5000. That equals to 0.015. Thus, the limits for the proportion of bad pineapples in the consignment are p cap plus minus 3 root over p cap, its q cap by n equals to 0.130 plus minus 3 into 0.015, that's equals to 0.085 and it's 0.175. Okay, hence the percentage of the bad pineapples in the consignment lies almost certainly between, one is 8.5 and another one is 17.5. So here's the problem number 2. So here the problem number 2. A random sample of 5000 apples, it's not 5000, sorry, it's 500. A random sample of 500 apples was taken from a large consignment and 60 were found to be bad. Obtain the 98% confidence limits for the percentage of bad apples in the consignment. Now, here's the solution. We have P equals to proportion of bad apples in the sample, that equals to 60 divided by 500 equals to 0.12. Since significant value of Z at 98% confidence, coefficient level of significance %, is 2.33. Now 98% confidence limit for population are P plus minus 2.33 root over PQ by N, that equals to 0.12 plus minus 2.33 root over 0.12 into 0.88 divided by 500,000 of it's 500. 0.12 plus minus 2.33 into 0.000212, that equals to 0.12 plus minus 2.33 into 0.01453, that equals to 0.08615 and 0.15385. Hence, 98% confidence limit for percentage of bad apples in the consignment are 8.61 and the second one is 15.38. Now we are going for the third problem. It's problem number 3. In problem number 3, in a sample of 1000 people in Maharashtra, 540 are rice eaters and the rest are fat eaters. Can we assume that both rice and wheat are equally popular in this state at 1% level of significance. Okay, and the solution of this problem. So in the usual notation we are given n equals to what? Yeah, it's 1000, and capital X equals to what? It is the rice eaters, and the value of the rice eaters is 540. Then small p equals to, as similar as the previous one, capital X by n, that equals to 540 divided by 1000 equals to 0.54. Null hypothesis 80, both rice and wheat are equally popular in the state, so that capital P equals to population proportion of rice eater in Maharashtra, that's equals to 0.5, and implies that capital Q, as the previous problem, Q equals to 1 minus P, so there it is 0.5 also. Alternative hypothesis H1 P not equals to 0.5. Then test static under H0. The test static is, what is the test static? The test static is Z equal to small p minus capital P. Please write it carefully. It's small p minus capital P root over capital P capital Q divided by n is to capital N 0 1, since small n is large. Now Z equals to 0.54 minus 0.50 divided by root over 0.5 into 0.5 divided by 1000, that equals to 0.04 divided by 0.0138, which equals to 2.532. Conclusion: the significant or critical value of Z at 1% level of significance for two-tailed test is 2.58. Since completed Z equals to 2.532 is less than 2.58, it is not significant at 1% level of significance. Hence, the null hypothesis is accepted, and we may conclude that rice and wheat are equally popular in Maharashtra state.